You've written your basic if statement. Congratulations. But then your code starts failing, not because the logic is wrong, but because of a missed order of operations or a missing escape hatch. You stare at the screen, pulling your hair out, thinking, all my code looks fine. Why is it choosing the wrong path? This frustrating moment, when your logic goes off the rails due to tangled and or conditions or messy multiple checks, is exactly what we solved today. The power of group flow prove is that it's recursive. Every single functionality down to an if statement. An if statement is considered a nested or a subgroup group with its own flow and prove. How would you feel to have a system to find out exactly why your if statement or statements are not working, or build complex if statements without the stress? We're going to use the group flow prove method today to turn tangled decision logic into a clear, prioritized, provable checklist. Step 1. Precedence in multiple decisions. The flow of decision logic is all about one thing, order. This order is called precedence. Precedence, when you have multiple decisions, they must be organized from most critical to least critical. I once took over a critical piece of code, a shipping calculator. The client was pulling their hair out because packages were being assigned entirely wrong shipping codes according to what they saw in the code. When they looked at the code, it should have returned one value, but it returned a completely different value, one sometimes for no reason. The original programmer's defense? I wrote it exactly how it was given to me, but the code was broken. Why? Because the most important shipping rules were buried at the bottom. The system was changing the shipping code 2 or 3 times because low precedence rules were at the top of the code and the high precedence rules were at the bottom, which we only found out by adding extensive logging to follow the shipping code all the way down through this process. This chaos could have been avoided if the programmer had taken what was told him and put his code into precedence order with escapes, not the order the customer had given. It's critical to know when precedence matters. So in simple classification order, things don't matter. They don't change the outcome. So if you have different colored armbands, for instance, red goes to the red room, while white goes to the white room, and gold goes to the VIP room. Since a person has only one band, checking for gold first or red first makes no difference to the final room that they end up in. However, when precedence matters is when you're sorting things like packages, and the rules can conflict. So items in small boxes, for instance, go to row A. Items in medium boxes go to row B. Items in large boxes go to row C. But the overriding rule is all children's toys go to row A, regardless of the box size. So if a large box is a toy, checking for size first sends it to row C. The children's toy rule has the highest precedence and should be checked first in your flow. The essential escape, always be escaping, is the next rule. So once you make a decision in your precedence order flow, you want to exit the function immediately. The correct tool for this is the return statement, which all languages support. The programmer who failed to use precedence also failed to use the return statement once the shipping code was selected. Had he done that, it would be very obvious what was or wasn't working. A single shipping code variable was repeatedly overwritten by other low precedence rules. You eliminate needless processing and guarantee the correct decision by using a return. So to give you an example, if zip is in zone 1, you're going to use maybe code UPS. And that's really not how you want to write that. The way you want to write it is if it's an oversized package, you want to return its freight. And then you want to check the zip code. If the zip code is in zone 1, then return UPS. So precedence matters, and it greatly simplifies your logic. So when we have mixed operators, there's a hidden precedence that takes place. The trouble begins when you mix them. Remember, in most languages, and has higher precedence than or. The computer groups the and expressions first. Imagine the condition to grant a manager access. The user must be in the admin group and they must be active, or the user's name has to be supervisor. You might write the logic as if is admin and is active or name is supervisor, then grant access. The trap, let's say is admin is true, is active is false, and is name not supervisor. Let's say it's Jane. As a programmer, you might look at this and expect false, since they're not active or the supervisor. And because and is done first, the compiler sees is admin and is active or name is supervisor. So that's true and false equals false. False or false equals false. But wait, let's change the example to show a more ambiguity actually fails the programmer's intent. The real trap scenario, the user must be a gold status member or they have to have a coupon and their cart must be over $50. You might write that code as if is gold or has coupon and cart total greater than 50, then apply discount. The fact that is gold is true, has coupon is false, cart is $30, not $50. You would expect the outcome to be false because the cart is too small. However, the actual outcome and before or, the compiler groups has coupon and cart total is greater than 50 is false, and false equals false. Then it performs the or, is gold or false, which is true. So or false equals true. The code applies the discount incorrectly. So the solution is to add parentheses to what we're doing. So we would change it to if in open parenthesis is gold or has coupon, close parenthesis. So if either of those conditions are true and cart total inside parentheses is greater than 50, then apply discount. And that makes it much less ambiguous, but it also makes it much clearer, and then it works the way we want. Another solution for the same issue would be nesting, another form of grouping and flow and following the flow of what's going on, which also brings in else logic. So another way to do it would be if cart total is greater than 50, then we want to check if it's gold or has a coupon, then we would return apply discount using our escape logic. Else, we're going to return no discount because they don't qualify for the discount. And if the if statement of if the cart is greater than 50, if it fails that, it's going to return no discount. If it's not gold and has a coupon, then it's also going to fail and it's also going to return no discount. The role of else and else if. Now let's talk about the else block. While the always be escaping method minimizes its necessity, the else is how we handle two things, sequential tests and default conditions. The structure if condition, statements, else if condition 2, and then statements, else, statements, is a single decision group. Critically, if the initial is true, the else if and else if blocks are never checked. This sequential nature means else if blocks are already showing precedence order. The final standalone else block serves as the default path, the logic that executes only if none of the preceding if or else conditions were met. If your main function is designed to return a specific value on every path, your final else block is where you return the catch-all or error value, returning the standard cheapest shipping code if no specific rules were triggered. It's essential definitely a low precedence final answer. So when we look at this from the perspective of flows, make sure that you think through the flow of your if statements and the code steps that need to be executed if the statement is true. And then prove, always keep in mind, make a list of how are you going to prove that this particular if statement worked, or each different case in this if statement works properly, and what to do if all of the statements are false. So let's talk about an alternative to the if-then statement, and that is the switch or match statement. Sometimes your flow isn't a long series of statements, but simply checking a single variable against a series of values. This is where the switch statement or match in Python shines. A switch is a clean way to handle the flow of logic when precedence is based on the value of a single variable. So you might have code that looks like this. Match zip code case 97005, return local A, 97010, return local B, etc. So in this example, when a match happens, we return the function. The switch statement is a value. If you have code below the switch statement that needs to run, you would assign the value to a variable and then use a break statement to exit the switch statement. Otherwise, the switch statement keeps executing code that follows the statement that was true. Then you have default, which acts as the else statement for the switch and match. Keep in mind the flow here is that you're going to be going down and checking the switch statements one at a time, and order does matter. And when you look to prove this, make sure that you cover all of the cases that need to be covered. To conquer complex control logic, you must impose structure. Group, define every decision and every condition as its own subgroup. Flow, order your groups by precedence and use parentheses and or logic if necessary. Use the return statement or switch match to always be escaping when a decision is final, making your code easier to prove. And prove, always be thinking, how can I prove this decision worked correctly? And with that, please press that like, join, and subscribe for more content like this. And leave me comments below.